Welcome back to my channel and to this short video about the difference of short and long mast for pump foiling. In this video I will discuss some aspects you should consider when you are in the process to decide what mast lengths you should choose for your personal foiling set. When I give training courses and people get to the point that they want to buy their own equipment, they often ask what different mast lengths there are and what they should go for. Should you decide for a short or rather a long mast when buying a pump foil set? Well, when you do your first attempts, you most probably do not care too much about the equipment. Most of us will just borrow the equipment from a friend or pass by a shop and ask for a suitable pump foil set to do the first attempts. However, once you really get addicted to pump foiling and consider buying your own equipment, questions will raise what equipment and what components to choose, and there is also the question what mast lengths you should go for. Checking the websites and the recommendations of some brands, you will see that not all of them include masts of the same lengths in their sets they recommend for beginners. Axis as well as Indiana both sell sets with mast lengths of 75 cm. The starter set of Hydrofoil DE comes with a 70-80 cm mast, Slingshot Hoverglide with a 72 cm, and Takuma also comes with a 75 cm mast. So we can say that most of the brands include in their sets, which they all call suitable for beginners, masts with a length between 72 and 78 cm, which equals a length of 28 to 30 inches. Same like with many other parts of your foiling equipment, also the choice of the mast length will be mainly dependent on the personal preference of the foiler and the intended use. Therefore, in this video, I will also not answer the question what mast length should you choose with a specific length. However, I will explain how the different mast lengths influence the pump foiling, and with that give you some hints what you should consider when deciding for a shorter or longer mast. First of all, let us have a quick look at the function of the mast. The mast connects the fuselage and with that the foil with the board. With that, the mast length is then also defining the distance between the foil and the board. Some may ask, why is the foil not directly attached to the mast? Well, first of all, the foil must be completely submerged into the water. Only with that, the water will flow around the foil and lift can be generated. In addition to that, we also want to make sure that during the up and down movement we do while pump foiling, we do not touch the water with the board, which would result in friction and with that the drag force against the driving direction. In other words, the mast length provides the distance which allows us to accelerate the board during the downward movement before lifting up the board again to complete the pumping sequence. Another thing we have to consider are the wave conditions, as the water will not always be flat. Especially in open water, we will be confronted with waves which actually reduce the length of the mast that can be used as a free height for the pumping movement. When foiling in choppy water, you have to ensure that you do not lift out the foil of the water when passing the wave hollow. In case the foil is not anymore submerged into the water, the lift will immediately be gone, and as a result of that, the foil will be pitching over the nose and most probably you will fall off your board. In choppy conditions, a longer mast allows you to drive your foil a little bit more submerged into the water, but still having enough height for the pump movement and do not run the risk of lifting out the foil when passing the wave hollow. Especially in case you consider to use the same mast also for other foiling activities, like for example wing foiling, a longer mast may make sense. Besides the aspect of foiling in choppy or flat water, there is another aspect we should look at. And that is most probably one of the main questions many people ask. Is a longer mast more difficult for pump foiling than a shorter mast? To answer that, and provide also an explanation, I have to back up a little bit. When pump foiling, you will move the board up and down, basically change the pitch angle. To do a turn, you will change the pressure on the board to left or right and induce a roll. Let us first have a look at the change of the pitch angle. To generate lift and speed, we change the pitch angle of the board up and down during the pump foil movement. But what is now the impact of a short or long mast here? To understand that, we need a quick recap on the forces and torsional moments acting while pump foiling. The force induced by the pump foiler is indicated with the purple arrow pointing downwards. The lift generated by the front wing is indicated with the red arrow pointing upwards, and the downforce generated by the back wing is indicated by the grey arrow pointing downwards. To accelerate, the foiler turns the board over the nose downwards. Shortly before the board touches then the water, the foiler inclines the board upwards again. To have enough torsional moment, we have to ensure that we have enough weight in the front of the board. In my video Body Position, Importance of Keeping Enough Weight in the Front Area of Your Foil, I describe in more detail the effect of the torsional moments induced by the rider as well as the foils. To calculate the torsional moment, we multiply the forces induced by the rider and wings with the distance from the point we want to know the resulting torsional moment at. As the distance between the rotational center and the back wing as well as front wing is fixed, we can conclude that the more we move the body to the front, the higher the resulting torsional moment will be. Let us now calculate the effect of a shorter and longer mast for the pitch movement. In our example, we will compare a 70 cm mast with a 90 cm mast. We assume that we have the identical setup and the only difference will be the length of the mast in the two setups. The question we want to answer is, how do the two systems compare when we have the same position on the board and push the board downwards by the same tilting angle? To compare the two setups, we will calculate the resulting torsional moment. As the relevant distances will be dependent on the tilting angle, we will have to do some trigonometric calculations. For those of you who are interested into the details, I will explain and show here how it is done. We know that the distance from the mast to the back wing and front wing is in both systems the same. What we are interested in is the distance set, as the torsional moment will be calculated by multiplying the rider's force with the distance set. What we now want to know is how the distance set is changing in dependency of the tilting angle alpha. To calculate the distance set, we have to apply some trigonometric calculations. Applying that here, we see that the distance set is calculated by the sum of the 0.2 meters plus the distance y and multiplying then that sum with the cosinus of the angle alpha. What is still missing is the distance y. That distance we can calculate by multiplying the mast length with the tangents of the angle alpha. Inserting that now into the equation for the distance set, we can calculate the distance set for different mast lengths. The resulting torsional moment is then the distance set, the distance we have just calculated, multiplied by the force induced by the foiler. In the result we can see that there is a nonlinear correlation between the mast length and the resulting torsional moment when changing the tilting angle alpha. That may sound very complicated, but let me explain you in a simplified way how we can interpret the resulting formula and then conclude the effect of a short or long mast. If you compare the dimension set and the torsional moment for the two different mast lengths, you can see in the graph for the same tilting angle we will have different results. To make it even more visible, let us calculate now the resulting torsional moment in a short example. The foiler in our example tilts down the board by 5 degrees. The change in the resulting moment is for a 70 cm mast 61.5 Nm and for a 90 cm mast 79.1 Nm. That's a difference of 28%. Keep in mind that the only difference in the two setups is the length of the mast. Everything else is the same. However, the difference in the resulting moment is quite big. What we can state is that with a longer mast, the changes in the tilting angle have a bigger impact on the torsional moment than with a shorter mast. Or, in other words, we can also say that with a longer mast, the pump foil feels less stable as it reacts quicker to changes of the foiler's position. Stating that the longer mast is less stable as the changes of the rider's position have a bigger impact when using a longer than a shorter mast could on the other side also be called that it's more agile. The same will apply also for the roll axis. For the roll axis, we can in a similar way calculate the displacement at the given roll angle and with that the resulting roll moment. As a conclusion, we can state that with a longer mast, the changes in the roll angle have a bigger impact on the torsional moment than with a shorter mast, which leads to a more responsive behavior. The last aspect I would like to discuss here is the height of the dock. When you have the foil only slightly submerged into the water during the starting phase, the so-called usable height for the pump movement is the biggest. However, we always have to consider that the longer the mast, the higher you will have to jump onto the board. So in case you generally start from higher docks, you will benefit more from a longer mast. However, if you generally start from lower docks, the height for the pump movement that you gain with a longer mast will get to its limit based on your jumping skills. So let us summarize what you should consider when deciding for the ideal mast length for your foil. A longer mast has the advantage that in choppy conditions you can submerge the foil a little bit more into the water while still having enough height for the pumping movement and at the same time reducing the risk of lifting out the foil of the water when passing the wave hollow. In case you consider about using the same mast also for other foiling sports, like for example wing foiling, a longer mast may be a better choice. However, a longer mast will also be less stable. Due to the longer mast, already small changes of the rider's position will have a bigger impact on the roll and pitch movement, what could be perceived as less stable. A longer mast may give you more pumpable height, however, when starting from lower docks, this effect cannot be extended unlimited as the maximum height will be limited by your maximum jumping height. I hope with this video I could highlight some helpful aspects you should consider when deciding for the ideal mast length for your own foil setup. May some of you now say, stop, you forgot about the weight of the mast. Yes, you are absolutely right, I did not mention that. For sure, generally, a longer mast will be heavier than a shorter mast. However, we would then have to look also at different materials, what would be a topic for itself. In case you liked this video, please feel free to sign up for my channel and or leave your comments below.